We're going to have two forms that we deal with. We're going to deal with vertex form. We're going to deal with standard form. You'll learn to love both of them, but we're going to start with vertex form. You guys with me, or yeah, maybe? Okay, so we're going to break this apart, and you learned all this stuff in 3.0. So you already know it. It won't be a big surprise. Well, it might be a big surprise, I don't know. A couple of things. A degree of 2 means it's what type of function? It's a quadratic.
That's parabolas, right?
And that is a parabola. So the type of function it's a quadratic, but the shape it makes when you graph it is that parabola. So parabolas are the graphs, and the quadratic is the type of function. In grade 12, we are going to deal with like cubic functions and quartic functions and all kinds of other degrees. Grade 10 was straight lines, grade 11 is parabolas, and then in grade 12 we kind of go crazy and do all the rest of them. Okay, so the variable up in front we call a. So a is just a number, that's a coefficient. So the coefficient, this controls the direction, and when I say direction, I'm talking about the up, down. So if it's opening up, is a positive or negative? We did this yesterday. If it's opening up, it's going to be a positive number, and if it's opening down, it's going to be negative. And again, you guys can write whatever you want on these notes. If you don't like my notations, please feel free to use your own. Okay, and the A controls also the width of the parabola. So what do we know? We know if it's a fraction, it's going to be wide, or is it going to be skinny? Wide. So between 0, if A is between 0 and 1, it'll be a wide parabola. And if it is greater than 1, it will be narrow. So this is all the stuff we did in 3.0. We went through those examples, we made some assumptions, but we made that assumption way back on Thursday of last week. So, okay, H represents the x-coordinate of the vertex. Remember that the sign is opposite to the coordinate. So this was a question from 3.0. It said, create an equation where the vertex is at 8, 0, right? So you knew your vertex, and your vertex was at 8 and 0. So if we were to put this in vertex form, we'd have y equals, and we said a was 1. So x would be, the x portion goes in here, but what's the sign? Is it plus or minus? Minus. It's always going to be opposite, right? So if it's a positive 8, then in the brackets it's a subtract 8. So if you haven't done that question, look at that. You just got that answer. And straight up, the y-coordinate of the vertex is k. And if it's at a positive 3, it's plus 3. If it's at a negative 2, it's minus 2. It's straight up for the y-coordinate of the vertex. Okay, so here we go. I think I'm going to skip this for a second, just because I think we need to get comfortable with table of values first, which we did in 3.0, but we're going to get a little bit more better at it. The first thing I want you to do is I want you to identify where the vertex is. And then we're going to create our table of values from there. So step 1, tell me the vertex. So looking at that, what is the coordinate of my vertex?
2.
Mm-hmm. And?
0.
It's the one that's added to the end, so it's 2 and 3. So that's my vertex. So just by looking at that equation, I know where my vertex is. So now for step 2, we're going to create a table of values, but we're going to be really purposeful. Remember how my favorite values were -2, -1, 0, 1, 2? And that didn't always give us the full picture. Now we're going to be really purposeful. I'm going to drop my vertex in the middle. And I'm going to pick some values that are to the left of the x, which is at 2, and to the right. So if we were to put this on a number line, I got 2 in the middle, and I'm going to pick 3 and 4, so this would be 3 and 4, and then I'm going to pick 1 and 0. So I'm always going to drop my vertex in the middle of my table, and then I'm going to be really purposeful about the numbers I pick around the vertex. Because if I had used -2 to +2, I would have only got one side of my parabola, right? So this way, you're always going to get both sides if you know where your vertex is. Okay, now do some math. Let's fill in the y values. You guys are good at this. You can do this. And if you've got your table, then graph it. Or if you're copying my table, you can also graph it as well. Some things we need to make sure we do on every graph is we need to make sure we label the increments. So on the other graphs that I gave you, the increments were labeled, like, so what are the ticks going up by? I'm going to make every second one a whole number. But on my y-axis, I'm going to go up. Each tick is going to be a whole number. Oops. 2, 4, 6, 8. And you guys know that your increments can be different on the x and y axis. They can be different things. But if your x-axis on the positive is going this way, it has to be the exact same on the negative going that way. About parabolas, what makes them beautiful? They're symmetrical, right? So if your parabola looks a little wonky and it's not symmetrical, or like this distance here is 1 away, and this is 4, so if you go 1 away to the other side, this should also be 4. Like there's a pattern in this. So you can work smarter. It's still hard, no matter which way you cut it. But you can start to see the patterns. If I go 1 away from the vertex, I'm at 3. And if this one is 4 and I'm 1 away this way, this one will be 4 as well. If you're not ready to trust your math yet, which takes some time, you can go ahead and and just substitute it in. You'll never go wrong with that. So, does your graph have arrows on it? Yeah? That just means it continues on our time graphing every. Okay, so move on to the next one. What's step one? Step one is vertex. Find your vertex. So step one is find your vertex. So you're in vertex form because from just looking at this equation, you can see the vertex, hence the name vertex form. So, where's my vertex?
2 and -1.
Yep, positive 2, negative 1. Which way does my graph open up? Oh, look, I lied. Which way does my graph open? Up. Good job, everybody. And I know that because the 1/3 is positive. Is this graph going to be wide or skinny? Wide, because it's a fraction, right? So we're going to get a much wider graph. Now, sometimes they won't appear that way based on our increments that we use. Like this one looks a little bit wide, but it's not. It's just the increments that I used. If you put them all on the same coordinate plane, you'll be able to see them. So then step 2 is to create my table. And right in the middle of my table, I put my vertex. I always like to circle it, ladies and gentlemen. It's just who I am, what I do. You do not have to do that, but it just reminds me that it's a super important point. So I'm going to pick 3 and 4 and 1 and 0 again. Ooh, fractions this time. All right, you guys do the table of values. I'm going to freeze my screen so you can't see mine. Would it make you feel better if I said you can change it into a decimal? And go ahead. Sometimes graphing with decimals makes way more sense than fractions. Sometimes fractions will make more sense.
If it's 0.3 repeating, we do have to use the repeating, right?
Yeah, you want to put at least a line over it.
Oh my god. Oh. Oh. Forgot to do that.
Mm-hmm.
So when I solve the bracket first, do I have to times it by 1/3 first before I subtract?
Yeah. That's what I got. I find it easier to work in fractions. That's how my brain works. I know a lot of you don't like fractions, and it's just because you're not comfortable working with them. But let me show you some math on that 1/3 there. So I'm going to take y equals 1/3. I'm substituting in 0 for x. And I'm showing you all my steps just so you can see what I did here. So I'm going to have y equals 1/3 times 4 minus 1. Order of operations is I got to do my multiplying first. That 4 can be written as a fraction as 4 over 1. So y equals 4 over 3 minus 1. I know that 1, if I change it to a fraction, That was a lot of math, but I did that in my, like, because I work with fractions every day, and I know you guys don't, but because I work with them every day, this was stuff I could go, oh, I went right here, this is negative 2 squared is 4, 4 times the third is definitely 4/3. I know if I take 1 away from that, I'm left with a 1/3. So the more you practice it, the better you're gonna get with it. And it gets kind of ugly with the decimals when they're repeating decimals, like the 1/3, that 0.3 repeating. Did anybody finish their table? Did you guys get negative 0.67 repeating here? Did anybody get there? Yeah. And what do I know? I notice there's a pattern. If I go 1 away on this side and it's negative 2/3, if I go 1 away to the right, it should also be negative 2/3. That's the beauty of parabolas. So I don't have to continually do my calculations over and over again because I trust my math. But if you're unsure, especially on a test or a quiz, I might actually just get myself a piece of scrap paper and substitute it in. Again, you are perfectly okay if you use decimals. There's nothing wrong with that. Okay, so let's graph this. I gotta put my increments on first. And some of you will write positive 5 here and negative 5 here, and I'm also okay with that. There's nothing wrong with that. My brain, like I said, I'm not a visual person, so I have to write each increment so I don't screw it up. But that's something that works for my brain, and the more you practice it, you'll figure out what works for your brain. If you just put 5 and negative 5, I'm good with that. I'm going to use every 3. I'm going to go up by 1. I'm going by thirds because that makes way more sense when I'm doing these increments here. All right, so my vertex is at 2 and negative 1. At 3, I'm at a negative 2/3, and at 1, I'm at a negative 2/3. So you see, I kind of jump around my table a little bit. I graph those two together just because it makes sense to me. I can count the points away. 4 is at a third, and 0 is at a third. I did my increments by 3. 1, 2, 3. So I know each increment is a third. I'm taking that 1 unit and I'm cutting it down into 3s. So I made a decision about how that looked. And I mean, if you want to do halves, you know that 1/3 is less than a half, right? It's 0.3 and a half is 0.5. 2/3 is greater than a half. That's 0.67. Like, so you can estimate too. Like, it doesn't have to be perfect. I knew it wasn't going to use up too much room, so I did it this way. Our graphs will all look a little different based on what you do for increments. It doesn't mean your graph is wrong. People freak out all the time that our graphs don't look the same. It's if you use a different increment, your graph is going to look different. And keep that in mind when you're looking at my answer keys too. Okay. Am I good to flip the page? I see some people still graphing. I'm going to flip the page. No, I'm not. I'm going to wait for you guys to finish graphing. I'm going to have a goldfish while I wait. Okay, hopefully you're all done. What's a 0? What's the zero of the function? You asked me, I think, 40 times yesterday. So now I'm asking you, what's the zero? X-intercepts. Okay. So now that you know that, you're smart people. Two different types of questions I'm going to ask about the x-intercepts. How many? And this is what we're going to do in chapter 3. And the other one is where are they, or what are the values of the x-intercepts? We are going to get really specific into that into chapter 4. Okay? I might give you a graph and it's pretty obvious where they are. But if we look at this graph and I said, hey, where are my x-intercepts? How do you feel about that? How do you feel about that question as soon as I ask that? Not good. They don't cross at the right points. They're kind of ugly. What if I asked you about this question? Where are the x-intercepts? There are none. Right? So sometimes I'll ask you questions. If they're obvious, I might ask you where they are. But I'm going to ask you how many you have. So I need you to visualize. Okay. So first thing you're going to do is you're going to find where your vertex is from the equation. And find where your vertex is. You're going to figure out if your graph opens up or down. And then you're going to close your eyes. And you're going to imagine the graph. And you are going to tell me if there is 1, that would mean the vertex is sitting on the x-axis. So 1, 0, they're sitting on the x-axis. 2 zeros, it obviously crosses the x-axis. And then we have a situation with no zeros. So you have a 1 1/3 chance of getting it correct. Okay? And it's my step 3. Close your eyes, visualize, life's good. Okay. So let's do that. Whew. Step 1. Where's the vertex? So unfair.
Yeah.
Totally unfair. But kind of fair?
No.
No? Okay, fair. Is the x in brackets?
No.
Is there anything with the x?
Yes.
No, there's no brackets, there's no number with the x, it's just that coefficient on the front. There's no x thing there. What if I wrote it like this? Do you know where the vertex is now? This and this are the exact same thing. Because if you subtract 0 or add 0, it's going to have no impact on it. So we don't usually write it like this. But if you see nothing with the x, like x is not in a bracket, and there's just an x squared, you know that the x coordinate of the vertex is 0. So there's my vertex, 0 and -3. Which way does the graph open? I stopped myself from saying it this time. I'm pretty proud of myself. How do we know that it opens up? Is this guy negative or positive, right? So because this guy is the coefficient out in front is positive, we know the graph opens up. Okay, so now I want everybody to close your eyes. And I want you to visualize a coordinate plane in front of you. And I want you to put that point on there and then think about it. How many x-intercepts do you have?
Wait, which point?
The vertex. Put the vertex on. Okay, everybody's just like, I'm going to take a nap now. If you are a non-visual person like me and need to draw it out, that's okay too. My vertex is going to be somewhere down here, correct? 0, -3, So it's going to be somewhere on that y-axis. You guys told me that it opened up. So how many times does it cross the x-axis? Twice. Ask where they were. I just said, how many do we have? Okay, so for the next one, where's my vertex? How does that make you feel? Everybody okay with that? The x always does the different thing, so if it adds 2, it's really a negative 2. Which way are we opening? Down, because it's a negative. Okay, so you either visualize and see it in your head, or maybe you're going to draw it because you're a kid like me. How many x-intercepts do I have? None. So what do you think the last one has with doing no math? Probably 1, because I'm going to show you each of the examples, right? Because that seems like a nice thing to do. So law of probability says that it's probably going to have 1 x-intercept, but let's just do it for funsies. So where is my vertex? 2 and 0. There's nothing added onto the end, so it's an implied 0. Which way does my graph open? Up. Up, because the 2 is positive. So if I were to graph this, I know my vertex is sitting right on this. So I will have 1, 0. That's a really crooked coordinate plane. Okay. Now we're going to do the tough stuff. Okay. This will be on your quiz for sure. This will be on your quiz for sure. This is a strategy that we're going to use all the time to find equations of things. So we're going to do our best here. So remember that vertex form is y equals a bracket x minus h squared plus k. I don't think that's anywhere posted in my classroom, so I can't even point to it. I don't know. You might want to get a tattoo. Remember it. Or you can just commit it to memory, because there's other things you're going to need tattoos of. All right. So what do the h and k, where do I pull the h and k information from? Your vertex. So can we find our vertex? What's our vertex? X always comes first, so it's going to be the 2 and then the 1. Good job, everybody. And then what I need you to do is I need you to pick one other point. So step 1, we find the vertex. Step 2, I want you to pick a point. Next point. Thanks. Then I always, anything with a 0 in it makes me happy. Could you have picked any other point on the graph and get the exact same answer? Absolutely, you could. All right, so we know the vertex has special letters. We know that these are H and K. These ones are just another coordinate pair. So these are my X and my Y. What letter do I not have any information about? A. So we're going to solve for A. So we're going to put all that information into the vertex form. So we're going to have y, which is 3, a, which I don't know, x is 0. Now, am I minusing or am I adding 2? Minusing. Okay. And then I got MIK, which is 1. We're going to do some math. So now we're back in grade 9, maybe grade 8. Oh, sorry, it went off the page there. Vishwa, do you need me to zoom in? Like, would that be better for you? Would that be better if I zoomed in closer?
No.
You sure? Okay. All right, so step 4. We're going to create the equation. That is my little abbreviation for equation because I'm too lazy to write out the whole word. Welcome to math class. Okay, so what we're going to do is the things that we need. So the format is y equals a bracket x minus h squared plus k. Oftentimes when people are putting this back together, they forget that squared. Okay, things that must stay. The a has to be replaced with a number, the h has to be replaced with a number, and the k has to be replaced with a number. The x and y go back to variables. So when we put this together, we're going to fill in. So we put it at y. A is 1/2, x minus 2 squared plus 1. This is the answer to that question. This is going to be on your quiz on Friday, and it will be on your test, and it will be on your exam. Okay, so do what you will with this piece of information. It's not going away. It is a skill that you need to know how to do, and we will use the same strategy through like grade 12 and other courses on how we find this. Okay, now I'm going to give it to you as same question, but I'm not giving you a picture. What? But what have I given you? I've given you the vertex, and I've given you the point. This time I've just written it out. So much easier for me to do. I'd like you guys to solve for I want you to create this equation. I'm going to freeze my screen, you're going to do it, and we're going to see where we end up. Format, you guys know that? What's step 1? Find the vertex. Step 2, pick a point. Step 3, solve for A. And then 4 is put the pieces back together.